We're going to take a look at the wet sump oil system of a Cessna 172, and this system does not apply to every aircraft, but there's a good chance that it applies to most Cessna 172 training aircraft that are in use today. And the first thing that I'd like to point out is that this is a wet sump system and not a dry sump system, and the only difference is that in a wet sump system, it's basically a system in which the oil is located in a tank at the bottom of the engine, and when the engine is finished using the oil, gravity will then bring that oil back to the sump. Whereas in a dry sump system, that oil tank is separate from the engine, and it uses a second pump to then pump the used oil from the engine back into the sump after the engine is finished with that oil. So we're going to examine a wet sump system found in a Cessna 172. So first we're going to look at the description of the oil system in our pilot operating handbook, and for this particular Cessna 172 Papa model, it's in section 7, airplane and system descriptions, and it says oil for engine lubrication is supplied from a sump on the bottom of the engine. And this is the definition of a wet sump system, but we'll keep reading. The capacity of the engine sump is 7 quarts. 1 additional quart is contained in the full flow oil filter. Now, we're going to point out where it says full flow oil filter. Just a side note, there's 2 different types of oil filters. There's bypass oil filters and there's full flow oil filters. And the bypass oil filters take about 10% of the oil pumped from the sump. They filter it and then return it back to the sump, and the other 90% is then delivered to the moving parts of the engine, whereas the full flow oil filter is what we have, and it filters 100% of the oil pumped before it continues to the engine for its lubrication and cooling and cleaning purposes. And we don't really need to know this particular information, but it's just kind of nice to know that in our full flow filter, it does indeed filter out 100% of the oil before it's sent back to the engine. So continuing on. Now let's look at how the oil flows through the system. So we have the oil just sitting in the oil sump, and down here there's a strainer screen at the bottom of the sump, and this is simply to filter out any large particles from being sent through the system. And as the oil flows through the strainer screen, it immediately runs into an engine-driven oil pump. And if the engine's not running, the pump is also not running, and this is where the oil would come to a stop. But as soon as the engine is set into motion, the pump is geared to spin with the engine, and it'll begin to pump oil from the sump. So as the pump sends oil through the accessory housing, the next stop is the oil cooler. And the oil cooler takes advantage of the air that's flowing over the cowling of the engine, and it uses this process to cool the oil as the oil flows through the cooler itself. But as we read in the POH, before the oil reaches the oil cooler, it's redirected to a bypass valve. And usually the bypass valve is controlled by a spring, and when pressure is applied to the valve, the spring compresses and allows the fluid, in this case the oil, to flow past the bypass valve. But how exactly does the oil know whether to flow through the cooler or whether to flow through the bypass valve? Well, it's completely determined by the viscosity of the oil. So the viscosity simply describes the thickness of the oil. And oil contains a higher viscosity than other fluids such as water, and we've probably noticed from our experiencing handling the oil that it's indeed a thicker substance, but the thickness or the viscosity of the oil changes based on the temperature of the oil. So if you've ever flown a plane early in the morning and the plane's been sitting all night long and you're the first flight of the day, when we're doing our pre-flight and we're checking the oil, we notice that the oil on the dipstick drips very slowly, and that's because the oil is cold and it has a higher viscosity. It's more thick. But if you've flown at 4 o'clock in the afternoon after someone just brought the plane back on a hot day, not only is the dipstick scalding hot and difficult to touch, but when we check the oil, it drips off the dipstick very quickly. And this is because the hot oil has a very low viscosity and it's very thin, sort of like water. So if we look at the oil that's pumped to the bypass valve and the oil cooler, if the oil's cold, it contains a higher pressure due to that higher viscosity. This higher pressure will compress the spring on the bypass valve, and it allows this cold oil to flow directly to the oil filter without even touching the cooler. However, when this oil is hot and it has a very low viscosity, or it's very thin, it doesn't contain enough pressure to compress that spring on the bypass valve. So the only place it has to go is the oil cooler, which it will then be cooled and then sent to the oil filter. So now we have the oil flowing to the oil filter, and the oil filter also has a bypass valve built on the inside of it. And this is just in case the filter becomes clogged, and the idea behind this is that in the event that the oil filter does become clogged, we would rather have dirty oil sent to the engine as opposed to no oil at all. So just a quick breakdown of what the bypass valve looks like in the oil filter. We don't necessarily need to know this particular information, but it's nice to have an idea of what's happening in the filter. Now, not every filter will look identical to this, but this is kind of a general schematic of how the filter will function in case it gets clogged. These are the parts of the filter that we're going to mention real quick, and this is the cover plate, and dirty oil is sent into the filter through these holes on the cover plate, and it's then directed through the filter media, which filters out all of the particles, and then through the holes of the support tube, and then off to the engine for lubrication and cleaning and cooling. And you'll notice at the bottom of the support tube we have a bypass valve, which is built into the filter, and the process will look something like this. We have the dirty oil flowing through the cover plate and through the filter media, and then through the support tube, and then off to the engine. However, when the filter media becomes clogged, the dirty oil is still flowing into the filter, but now there's a high pressure which forces the spring of the bypass valve to compress, and it allows that dirty oil to flow through the filter and then off to the engine, even though it's simply just dirty oil. And this animation is very helpful, and I didn't make it. It's originally from Kelly Clark Automotive's YouTube channel, and feel free to check them out if you want to see other animations of engine parts, although they're mostly for automobiles. I don't think they're really for airplanes at all. But after the oil is directed out of the oil filter, it's then sent to lubricate, cool, and clean the moving parts of the engine. And along the way, the temperature and pressure of the oil are picked up by our oil and temperature pressure gauges to give us our indications in the cockpit. And as the oil is sent off to the engine, you might notice this little gadget here, and this is a pressure relief valve. And the idea behind this is to regulate constant oil pressure within the accessory housing and within the moving parts of the engine, and it operates pretty similarly to our bypass valve. And when the engine's moving at high speeds, so is the oil pump, and this is because it's geared directly to the engine. So when that pressure becomes too great, the spring of the pressure relief valve is compressed, and it allows oil to flow past the pressure relief valve, and it's then deposited back into the oil sump. And just one more thing I want to point out, because we have a wet sump oil system, after the oil moves through the moving parts of the engine, gravity will then bring that oil through the bottom of the engine and back into the oil sump, where its journey is now complete. And then the whole thing just happens over and over again.